Introduction to Profilometry with the Vico DECTAC 6M Stylus Profilometer. Profilometers allow us to measure topographic features because they use a probe with a radius typically on the order of 10 microns to make physical contact and raster across a sample and produce a profile or line scan. By plotting the probe movement both laterally and vertically, users are able to take height and width measurements. And besides surface topography, sample roughness and film stress can also be calculated from several scans of different areas within a sample. Here we can just make out the tower and the stylus. The tower is used to lower the stylus until the tip makes contact with the sample below. To the right is an optical microscope, which is used to help the user align the probe tip with a particular feature of interest. The first dial changes the focus of our image, and this second dial can change the magnification power for the microscope. This tiny bar allows for stage rotation along the z-axis. And these two stage adjustment knobs allow for X and Y stage movement. It's important to realize that the stage should never be moved while the stylus tip is in contact with your sample. This could result in significant sample damage, tip contamination, and could actually break off the stylus entirely. Using this tool requires some integrated software. Start by double-clicking the DECTAC 32 icon. Once the software has loaded, load a sample onto the center of the stage as previously shown. Now click on this icon, the sample positioning window. This switches to a view from the optical microscope. Next, click this icon, tower down to null position stylus up. This will bring the tower and probe down to your sample, but will leave a small gap between the probe and sample so that you can make fine adjustments to the stage. Now would be the appropriate time to change our focus and/or magnification settings if we desire. Also, we will now need to use our stage rotation bar as well as our X and Y stage adjustment knobs in order to properly orient our sample before running a line scan. Now we can click on this icon, Run Currently Active Scan Routine. This will scan the sample using the most recent scan parameter data. Here we see a few of these parameters, including our stylus radius, the length of the scan, and the duration of the scan. Note that increasing the duration and decreasing the scan length both result in higher resolution scans. This is what we see in the sample positioning window when we're actually running our active scan routine. Immediately following the scan, a new image appears, which is a graph of the height versus distance data acquired. The first thing to do is level the scan. To do this, we first need to move the R and M markers to two different points of the scan, which we assume to be level. Because this sample is photoresist patterned above silicon, we can assume that the low points are polished silicon and thus level. Using these arrows, we can spread the width of the markers. This has the effect of averaging the highlighted lateral data points. Now we can click on this icon, Trace Level, to level the trace at the current R and M intercepts. Once leveled, we can take some measurements. To measure the step height from the silicon substrate to the top of the photoresist, we must have one marker on the lower surface and one marker on the higher surface. We can see now in our results table that the vertical distance or average step height is about 1,440 nanometers or 1.440 microns. To measure the width of a feature, we must move the markers to opposite ends of the feature of interest. Now if we look in our results table, we can note that the horizontal distance is 43 microns. Now if we wanted to adjust our scan parameters, we would click on this icon, the Scan Routines window. This gives us some options. For example, we could change the scan length. We can click the scan length link and then enter a new value. Now in our case, we are satisfied with our scan. So to finish, we click back on the sample positioning window, and then we click the tower up to load position icon. This will return the tower to its rest position, and we can safely remove our sample from the stage. A profilometer is a tool which functions to reveal surface profile information. They are capable of measuring large range of feature sizes from less than a nanometer to several microns, making them very versatile. But remember, the hard tip makes contact with the sample and features being investigated, so soft materials such as thin films could easily be damaged. Also, sample damage typically leads to contamination, which can cause false information and distortions to appear in the acquired line scan. This concludes an introduction to profilometry and the Veeco DECTAC 6M stylus profilometer.